we ready to discuss? It's a pretty short article.
Fine.
Let's give it another minute or two, and then we'll get started. All right, let's get started. Yeah, this randomly crossed my radar, and it struck me as very funny, and also made me think of all the similar funny language problems with talking about technology. And just for the, I guess for a little bit of a creative change, I thought we could try and like discuss this. I don't know how well formed this discussion idea is, but yeah, one of the comparisons that struck me between all these collective nouns for birds and animals versus technology is it's like almost useful when it's like relatively well chosen, but then it becomes ridiculous if it becomes arbitrary, right? Like a pride of lions is kind of useful because yeah, lions do kind of like have that proud look when they sit around, right? So it does capture something real about them. But when you say something like Parliament of Owls or a murder of crows, it's kind of meaningless. And another example that occurred to me was sometimes actually using the right words helps you like make useful distinctions. So when you talk about geese, when they're in the air, the collective noun is skein. I think that's how you pronounced it, Skein. And when they're on the ground, the collective noun is gaggle. And when you don't know whether, or when you're indifferent to whether they're flying or on the ground, then you can just say flock. And that kind of useful distinction is like I don't know if there's a word for this, but how do you refer to a set of servers in a data center that are just like sitting around waiting for jobs, and then the set of servers that have been assigned to a particular task, like maybe a MapReduce program is running or something. Yeah, so you can use these nouns to refer to states as well. What else? Since a lot of the architectures in CADS type systems are basically network based, it's interesting to see how you use network language or graph language, right? So there's nodes and edges. You can talk about like more precise terms like directed acyclic graph, things like that. I remember when I was doing a lot of Simulink work back in the day. For those of you who don't know, Simulink comes with MATLAB. It's for drawing control diagrams. They used formalism called Harrell state charts, which basically, at the UI level, it's about like grouping nodes together to form super nodes. And I think I've heard terms like supernode around as well. But it all seems like super unsystematic, and different people just make terms up as they're using. Sometimes they're similar, sometimes they're not. Like Farcaster versus Blue Sky, Farcaster used to use the word hubs. I think they've changed architecture and used some other word for something else now. But Blue Sky had something similar, but I forget what it's called. And then, yeah, you have like specialized names like sequencer for L2s. Um, well, that's a single machine, not a collective, but it gathers transactions. So yeah, kind of all over the place. I'm not sure where I'm going with this topic, but just general thoughts on both this naming culture in biology as well as engineering. So let me, I'll pass around to Anant and then go down.
Yeah, thank you. And sorry, I was changing devices previously, so I don't know if I missed anything before. Yeah, this was very interesting and like I think comedic reading. I mean, for someone who's like I just casually look at birds and I can't even name the different species. And sometimes I go look at like national parks and they have they have these boards that shows the species that live around the region. So maybe if I get lucky, I spot them, but that's the extent to which I have, uh, engaged in birding as any serious activity. But it was good to read this article in that context because I always get very, I do want to develop a more serious sort of hobby or activity, let's say, but I often get like put off by the very sort of the birders community that is like very specific about all of these names and so on and so forth. So I always found it very intimidating. But reading this article was actually good in the sense that even the academic what do you call them, like ornithologists, even they seem to not use some of these terms, and they just describe things as what they are. But although uh, so that was very interesting for me from, like I said, from like another perspective. And the other article that I shared specific to CADS is all of this. Uh, 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 the Big Ball of Mud and Other Architectural Disasters article that I've always found it useful, given all of this different ways software architecture can grow unwieldy. And anyway, so I think that tells me that having some form of language around describing uh, uh, the the species or the specimen is obviously useful, but sometimes, yeah, uh, it is funny to step back and think about how these things have come to be. And often I also find myself that even once I kind of reason about like why things are named they are, even if they are, it doesn't make sense logically, but once I understand whatever the logic built into naming things systems, I find that it's often easy to follow along. And also, this makes me think that I was recently talking with someone on um, on like the whole crypto ecosystems and the crypto like different blockchains and so on and so forth. And like they were basically questioning very hostile, and they were questioning like what is even the point of this, and like what does it actually bring. And so they asked me to explain, like, can you explain why this is important in like one sentence? And I found myself thinking about like Byzantine fault tolerance. It's like, isn't that important? Like, sure, to start there. And yeah, that's an example of like how, yeah, like the terms as sort of made up as they are, it's useful to sort of get at a point. uh right, so that occurred to me. And the other uh 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 yeah, so the murmurations is actually also interesting for starlings. I was uh yeah, like I was recently somewhere, and I just found about how the murmurations as a protocol work, right? Like it's quite simple in like in its design, but it often forms like very interesting emergent patterns, and there's a term for it. And before knowing the pattern, I had assumed that there must be some complex ecological signaling going on between like a group of or a flock of birds, and turns out it doesn't. So that was also interesting in a separate context. The other thing I was thinking is also. Uh, I gave this article to ChatGPT and like I was asking it to come up with some fun examples, and it really struggled to come up with fun examples. I guess this is to like its recent points on like the AIs being like not good at humor or irony in general. But one thing that occurred to me as part of my ChatGPT dealing with this was, uh, yeah, the idea of APIs, right? Like we use APIs to talk about different interfaces between different applications, but all of the architecture terms we talk in microservices and service-based architecture. And so, what's the distinction between a service and an application? It's I mean it's fuzzy, but again it's these are the details that I can imagine like for somebody not in the know can like can make them go mad. And it reminds me that in general, like other ways that I've been using AI, I mean LLMs in general, is like it's perhaps it's in the architecture is as a translation layer, right? So the translator is instead of translating from languages as we classically know them into another languages, it can be used to sort of translate these specific terms that specific industries and applications use into another terms, uh, another way of describing them that other people with other domains can make sense of. So that's been a really sort of an interesting way that I've been using LLMs for communications, like into the different stakeholders and like different people with different domains. Um, yeah, this is a rich topic. I can think of many other uh, examples where it trips me up and like uh, and like those trip ups actually helps me understand things better. Yeah, I don't know if there's more thoughts I have, but I'll stop here and I'll pass it down to Anuraj and we'll come back for second round.
Yeah, it's let's say funny article. It reminded me of my struggles with vocabulary in like when I was preparing for GRE like 15 years ago. So I'm not that good with words and vocabulary, and I always hated the vocab part of GRE, and like I didn't understand why it was there. So I kind of share what the author is trying to say, and then like there are a lot of like I had like friends who were much better at vocabulary than me. Like, and when they would try to like show off their vocabulary, I would just throw in that Richard Feynman video at them. Basically, Richard Feynman says that you can know the names of lots of stuff and still not know the underlying concept. So, as a joke, I would send it to them. But I do understand that, like, if you have like a good vocabulary, then you can describe certain concepts in a more precise way. So I wish I had like enough vocabulary for all the fields I want to study, but currently I don't, and then I don't know how to increase it. Maybe so in certain fields which I am working on a daily basis. For me, that's easy. For example, when I was trying to do a mechanical design of the wheel, I needed axial grooves on the circumference of the wheel, and it took me like 30 minutes to figure out these four words, and then I would get different designs because I couldn't just describe it in a very precise way. So these are the things like I wish I had more like things, but or more knowledge, but like yeah, uh, currently I don't. So yes, so I kind of share what the article wants to say, but on the other hand, I know that like describing something in a very precise way is like a good skill to have. Maybe passing on to Ben with the thought.
Yeah, so when I read this, what I think is like there's always a trade-off between, your words being, more common with other things. something that people might like something that's historical versus something that is more maybe specific to your situation, but people might not understand. Like I just thinking an example, like in the crypto space, there's the use of the word validator to describe sort of people who act in the network, which isn't quite actually just doing the validation. Like you can easily run it's the word is separate from full node, which is the fully validating node, which does all the validation. But if you don't stake, you're not technically a validator under, say, Ethereum system. Um, so at points fell to the word finality generators. Um, or maybe and then there's stakers, but then staking actually encompasses multiple things versus block generation, what I call finality generation, because you can have one without the other. Well, you can have block generation without finality generation, but not the reverse. Um, and so there's all these little but if you say something and people aren't you know listening aren't like used to it, they can get confused, even if it's you hope it's pretty obvious. And then there's always terms that maybe made sense in the past, but things change and they don't quite make sense anymore. But then do you change them? Um, and I mean, this is mostly stuff that's like different than but maybe I'm sure some of these terms in the past were more heavily used because there is useful information there, as Venkat said. Like sometimes, like a murmuring of starlings actually, that gives you some information on how they actually behave. Um, but then there's as you leave that, sometimes that becomes less important. Um, so I don't know. It's certainly an interesting thing to think about. I've run into myself in trying to name things. Like, do I try to make the name more? My instinct is always try to make the name more exact, like, and not just use a historical term that might not be fully accurate. But that can also cause problems too. So I'm not sure I have too much else to add. Um, I think I will pass it back down to Venkat, I guess.
Yeah, floor is open, and perhaps since we have time, I'll throw out separate prompt. Like specifically when you talk about composable and distributed networks, uh, I'm interested in like what becomes easier to see and what you become blind to when you use specific terms, right? Like, for example, if you use the word stack, that's a distributed system that's composed in a particular way, which is vertically. And when you see an abstract stack diagram, like the OSI network stack, it looks clean and elegant, right? Like 7 layers with neat names, and you think it fits. But then you look at an actual stack diagram, like I saw one of NVIDIA's basic AI architecture recently. You can see like how completely messy it is. Like in NVIDIA's case, you've got CUDA as a horizontal layer, Mellanox as a weird like framing layer, there's vertical bars, all sorts of things. And then you think of like the XKCD cartoon of infrastructure, right? That looks like a Jenga tower with multiple vertical and horizontal blocks. So if you use the term stack, it kind of forces you down a path that like constrains your architectural imagination to be primarily vertical, and then anything that doesn't fit the vertical scheme, you kind of like don't see it as clearly, and then you have to like fit it in weird ways around. um, like think what would happen if you take something you're trying to like think of as a stack and redescribe it as say a DAG, right? A directed acyclic graph. um, would you think about it differently? Would it be organized differently? Like a lot of decentralized systems, you can't really describe them as stacks, uh, even though there might be like a loose hierarchy of like in Ethereum, you've got like the light nodes layer, then the I guess full nodes, then the archival nodes. So that might be a kind of like weight stack or something. But the fundamental grain of the system is not a vertical stack. It's more like a network, but it's not clearly a network. So language of like nodes and edges doesn't really work. Like what is the mempool? So the mempool is kind of like this floating cloud sitting around a bunch of nodes, I guess. I don't know. And how does the idea of a fork fit in with the language? So yeah, there's something very unsatisfactory about like um, just purely chaotically emergent language, which obscures your thinking. Anyway, floor is open.
Yeah, the name mempool kind of also is yeah, confusing, because for a long time I didn't know like where are the transactions like collected. So, but there seems to be some sort of a gossiping via which the mempool gets all the nodes get the knowledge of mempool. But from the name it seems that it's a single location, but it's actually not, right? It,
Yeah, my mental model for what the mempool actually is basically like, aircraft over an airport waiting to land, like, landing permission. So there are like all these transactions flying around, and until they get landing permission, they're not included in a block. So maybe a better term for mempool would be, I don't know, mem space, like airspace. I don't know. So, but it sends your mind in a completely different direction, because now you'll think in terms of like how long have things been waiting, what altitude are they waiting for, things like that.
Yeah, that's actually a pretty good analogy. I think I like that mem space. Though not sure mems. It really comes down to the fact that, mempool is interesting precisely because, it sort of by design can't be a single thing. If it was, if people could agree on the mempool, it could just be the blocks. And so, you end up, and then with MEV stuff, you end up with stuff like dark mempools, hidden mempools, people trying to skip the mempool and go directly to some kind of generator so they don't have to, deal with the possibility of their transaction being acted on before it's confirmed, that sort of stuff.
I think that made me think about this, like think about stacks and other ways of calling the systems. Like topology it seems like an example, like a sort of a term that I can find myself thinking about. Like you can have topology in terms of the geometry, and the geometry can be described as a set of, at various levels of abstractions. You can have like 2D faces and 3D volumes, and you can have lines, and which are basically edges and points as nodes. And like you can think of like very interesting constructions uh, with those type of primitives. And even like thinking about network as in terms of topology, I find like maybe that's something there. I'm not sure. The other thing related to that is like uh, essentially I mean, in the world of simulations, the world that I'm sort of familiar with, like you often think of like turning this abstract geometry topology, which is like dumb geometry, into like a computational geometry. And then the computational geometry can deform and shear and like, can go through all kinds of transformations. So that's like one way I try to make sense of these um, networks outside of stacks. But I'm not sure if that's fertile, but that just occurred to me.
Yeah, I think that's actually a very interesting direction to go in, and it's actually very um, critical right now in AI, because in AI, the capacity and capability of a system is directly related to the topology of the memory architecture at the largest scales, right? So physically, you've got the um, chips on a board, boards in a, blade, so server, and then servers in a rack. Then the racks are like side by side. If you look, say, at an NVIDIA system, you'll see like around 6 racks of about, I guess, 8 systems each. In the middle, there will be a storage rack. So this is like a big rectangular cuboid, and that's a particular spatial physical topology. But typically, when you want to like architect the computational geometry, you might construct something like a torus, or other like continuous topology out of it, or donut, or uh, star, or something like that. And one of the interesting challenges that happens in the translation is the latencies up the memory stack. So now we have another kind of intersecting topology, right? Because memory is not just like a large addressable space, it's also a stack going from like SRAM to layers of cache to persistent and so forth. So there's that hierarchy. And then there's this physical spatial topology. And that one, depending on like if you pick any two processors, they might be connected next to each other kind of on the same SoC, or they might be connected via PCI Express, or they might have to go through Ethernet or InfiniBand. And those physical connections will have very different latencies. So even if your abstract computational topology is, I don't know, a fully connected graph where logically any processor is like equally well connected to any other processor, practically it's not true. So what they end up having to do is all sorts of retimers and like timing juggling black magic shit that happens. So yeah, I think that's an important consideration when you kind of almost compile a conceptual topology with a particular kind of name like a torus down to a physical configuration of like actual hardware. Um, this actually makes me think of the geese example, right? So when geese are flying in the air in V-shaped formation, it's called a skein. And maybe one way to think of it is the air is much less constrained, so they can be in like clean geometries. But when geese are on the ground, there's like obstacles and bushes and other things. So they usually have much looser and chaotic looking formations. They're not in like V shapes or anything. So there's an interesting almost compilation thing of like the abstract collection geometry or topology and how it gets compiled down to the physical hardware layer.
The other term I was thinking about is call data in EVM. So I like generally work with register machines in SOCs and microcontrollers. So my vocabulary is completely on like register machines, but like so I can't intuitively grasp what's happening on a stack-based machine like EVM because like kind of the vocabulary is like I have it missing.
The I mean, the other thing that reminded me is like, I mean, your register abstraction, Raj, and I think it's keys example reminded me that uh, the I mean, in the article that I shared on the big ball of mud, there is a term. I'm just trying to find the term. It uses uh, sorry, sweeping it under the rug. It seems like a lot of the complexities are basically swept under the rug for most people. Like in the AI example, like all of the complexities that goes into orchestrating a data center and multiple data centers, maybe in some cases, to like that can be like the geese on the floor in many ways. I guess that's where it's going. And like the way people sort of think about AI and like use AI is kind of like this clean formation and this interface that just that feels magical to most people. So that was interesting to sort of think about how people experience or like whatever their experience with the systems is entirely a function of like what level of abstraction they are often find themselves in. I guess that's related to concurrency in some sense that goes up and down. But
Yeah, and one of the dangerous mistakes you can slip into is if you use terms that point at overly clean mental models, you make mistakes about like things like size and capacity. Like I was just remembering, like Elon Musk is now making a big marketing, drama out of the term. What is it? Gigawatt data centers, is it? And Arvind Narayanan, in one of his like critical comments, was saying something like, just because a data center uses a gigawatt doesn't mean you have a gigawatt worth of intelligence, right? Because it actually matters. Like it's very easy to pump a gigawatt of power through random circuitry that does nothing. It's really hard to like mm, pump a gigawatt through hardware in a useful way with all the configurations able to actually use it to generate intelligence. And there's another one like this. Oh yeah, like if you think about that old kind of bullshit statistic uses only 10% of their brain, turns out it's bullshit. Like if you do the neuroscience correctly and the imaging correctly, different parts of the brain do different work and they're active at different times. And it's kind of bullshit to claim that you only use 10% of your brain. You use a lot more of it, just in a more complicated way. Yeah, but on the other hand, yeah, I mean, it is kind of like useful in the sense of like Fermi estimates to come up with the big overall boundary numbers. Like a gigawatt scale AI data center should be understood at that's the maximal capacity. It's like, that's how much you can get if you're able to like completely optimize um, how you deploy the orchestration in that gigawatt of infrastructure.
That reminded me of Tetris. Tetris is a useful metaphor to talk about this. Anyway,
Yeah, and I was just connecting it back to crypto. Block space is an example like that, right? Or block or blob space. So both are kind of used as very fungible GDP or gigawatt level terms. But I wonder, like, what happens if you actually poke into block space, how it's used. Same with blob space is probably even worse. Right now, I think stablecoins are using most of the blob space. I don't know what they're using it for, but yeah, I would like to poke at block space and blob space. I think they're both big balls of mud at the moment.
Actually, I was just vibe coding a app that would help me visualize. Well, there are websites already, but just to get an idea of what the different things are, he was just on my site, quest. I try to build an app that would help me visualize all these terms.
Any more thoughts? Right. If not, we'll call it early. Hope that was an interesting lateral thinking break. See you guys next week for the Ethereum track.
thank you. That was fun.